Hello everyone. In our last few sessions, we have learned about functions, definition, presentation, maybe in terms of graphs. We have learned a lot many things. Types of functions also we have learned. Now understand one thing, that my emphasis throughout has been on graph. And in that direction, we have already taken the quadratic polynomials and linear polynomials. Now quadratic polynomial, when we try to draw graph, that is y equal to ax square plus bx plus c, that coefficient a mattered to us. That coefficient of a decided the direction of the graph. This much you have already done. Now in this session, let me start with first a cubic polynomials graph. Now ax cube plus bx square plus cx plus d. In this, ax cube matters to us, like ax square in the quadratic one. Now ax cube tells me that if x is negative, x cube would be negative, and if x is positive, then x cube would be positive. And to term x cube, a is multiplied. So a also has some role to play. Now let me try one graph that will give you more clarity. For a greater than 0, I have drawn two graphs. In first graph, you are seeing that graph meets the x-axis at three distinct points. And in the second graph, you are saying that graph meets the x-axis at one point only. Now, at how many points that curve meets the x-axis has got something to do with the zeros of the polynomial. Now, a cubic polynomial has odd number of real zeros. So, minimum one real zero it will have. So, the value of y at that zero of the polynomial will become 0. So, in the second graph, you are seeing that this corresponds to only one real zero. And the first graph shows you, the left one, that shows you, or that curve meets the x-axis at three distinct points, means three real zeros. Now, these are the things which algebraically we have seen. Now, you are seeing in the picture form. Now, I have not drawn here graph which may be corresponding to a less than 0. That you may try on your own. Now, let me move to the next one. That is y equal to 1 by x. X not equal to 0. That's obvious. Now, when you look at y equal to 1 by x, you realize that y will change its behavior as x changes, but it would be in its reciprocal form. Means, if x increases, y decreases. Or if x decreases, y increases. This is what we have understood. Another thing what takes your attention is, I have written there only x not equal to 0. When you are saying x not equal to 0, then either x is negative or x is positive. If x is negative, then even y will be negative. If x is positive, then even y will be positive. So what are you expecting in its graph? That graph we are expecting in the first quadrant or in the third quadrant. So draw x-axis, y-axis, show the origin, and keep these things in mind, that when x is very small, y would be too large. I'm talking about positive x. And then keep increasing x, you will start seeing that y decreases. And similar behavior you observe in the third quadrant also. Another thing, when you look at the graph, you must have noticed that since graph lies in the first and third quadrant, what does this remind you? Does that remind you of odd function? Yes, it's an odd function graph. It is symmetric about the origin. I mean, these are the properties one must understand when you look at the graph. Now, let me move further. Now, I am going to take something new to you. I have written there at the top as heading, the graph of exponential functions. Now, exponentially decreasing, exponentially increasing, these English words, I hope, you must have heard before. When we say exponential, that means drastically increasing or drastically decreasing kind of thing we are expecting. Exponential function in mathematics is a special function. It is most of the time written in the form a raised to x. Now, when I'm saying y equal to a raised to x is my exponential function, that a matters to me. Now, a has to be positive. And then I have written there a less than 1. So, your guess may be right that I may have another case as a greater than 1. Now, why I'm talking about only a less than 1 or a greater than 1? Some of you may think, can we have a equal to 1 also? Yes, you can have. But the thing is, 1 raised to x no one would study because it's always 1. So we will be studying only two cases. that a between 0 and 1 and a greater than 1. Let us try that. How does graph look? Draw x-axis, y-axis, name them x, y, and see the graph. Graph starts from second quadrant, from top, and it comes down. This is what we are observing in the first graph. Let me take the second case, a greater than 1. Again, draw x-axis, y-axis, and see the graph. It's continuously increasing up. So, behavior changes. When you see two graphs, what do you observe? In the leftmost graph, that curve comes down. And when you see the graph on the right hand side, that curve goes up. So that means there is something more to study. And what do we study? What do we observe here? We observe for a less than 1, that is the left graph, that a raised to x decreases as x increases. And in the second graph, I mean on the right, that a raised to x increases as x increases. So the left one, we will say it decreasing graph, and the right one, we will say it is increasing graph. Now, do you observe that both the graphs or both the curves, they are fully above x-axis. They do not even meet x-axis. Means a raised to x is not 0 anywhere. A raised to x is not even negative anywhere. It is always positive. That does not depend on value of a. Mind you, please, in both the graphs, similar observation we are making. Then, next, I observe that for x less than 0, look at the graph, look at the curve on the left one, and observe that the dotted line which I have drawn at height 1, the curve is above that line. But in the second graph, it is below that line. And that is what we have written in the statement as, when a is less than 1, a raised to x is greater than 1, and a raised to x is less than 1 whenever a is more than 1. Now, can you write similar statement for the second part? Second part, I mean for x greater than 0, what happens? For x greater than 0, for a less than 1, a raised to x is less than 1. And for a greater than 1, we are observing that a raised to x is more than 1. So, such observations you can always make whenever you see a graph. You should be able to write. I am saying write. Actually, in my normal classes, I would have said that you should be able to read the graph. It's like learning a language. Graph also speaks with you. Mind you, please. Now, let us move to next. And the next is graph of logarithmic functions. Now, exponential and logarithmic function, they go hand in hand. One is inverse of other. You have already seen what I mean by inverse of a function. Now, whatever job exponential function does, logarithmic function finishes that. Or whatever logarithmic function does, exponential function finishes that. Reason that they are inverses of each other. Now, one logic could be that if one is inverse of other, I mean exponential inverse of log, or log is inverse of exponential, then can we use the basics what we have learned in inverse of function? What was that? Recall. We had seen that graph you can draw by taking image of one function in line y equal to x, and the image would be inverse function. Now, if you want to do that way, you are free to do. But let us at least see what could be shape of logarithmic function. Even log function has been defined for values of a less than 1 and values of a greater than 1. So, first one is for a less than 1 and a has to be positive. Now, graph is something like this, which is a decreasing one. I mean, it starts from the top and it decreases. One more thing you can observe, there is no part of the curve on the left side of y-axis. I hope everyone can see that. Means what? That log function is defined only for x greater than 0. This is the observation what you can make from the graph. Now, I try to draw graph for now a greater than 1. Again, similarly, draw x-axis, y-axis, name them and see the graphs. The curve starts from down and goes up. And again, it is on the right side of y-axis. What does that mean? That log function is defined only for values of x which are greater than 0. Now, like in exponential function, can we write few more observations? Now, observations are, when a is less than 1, log x decreases. Can you see that? Yes. Graph starts from top and comes down. So, a raised to x decreases as x increases. And also for a greater than 1, what are we observing? That log x, yes, increases as x increases. So, because it's an increasing graph. I move to next. I observe that for x greater than 0 only, you can draw the graph of log x. This I have already mentioned. Now for a less than 1, one more observation I see, that whatever values of x you are taking between 0 and 1, log x is more than 0. And log x is less than 0 for all values of x between 0 and 1. For which values of a greater than 1. I make one more observation about both the graphs, that log x is negative whenever x is more than 1 and a less than 1. I'm talking from the first graph. And the second graph, when you see, what do you get? That log x is positive or greater than 0 for values of x greater than 1. And that is for a more than 1. Now, these are the observations about logarithmic functions. Now, these are the properties, if you wish, you can use whenever you are dealing with logarithmic equations or logarithmic inequations. And similar way, exponential quantities properties also or observations you can use when you are dealing with exponential inequations or exponential equations. These are extremely important observations. Please try to revise them as and when possible. When we meet next time, we will come again with something new. Till then, stay tuned. Thank you.